In the last video, we went over this example, and I realized instead of going over a more complicated example, I would like to spend more time going over this for loop and sort of dissecting it and tell you about the sort of flexibility that you have with Java. So let me get this going. So let's say I'm just going to write this again. So just going to, actually I need the colors. So show colors. So yeah, my colors here. Okay. So let's just write the class again. So public class and then iteration. So iteration. Let me just get this straight. Okay. So iteration. Open bracket, close bracket, and then public static void. Let me just do this right. Void main string args. So the for loop we had previously it looked like this. So we had, oh, actually, I don't want this. I want my pen to be green. So let's have this here. Yeah, just make sure. Green. Yeah, so the for loop we had was for int I equals 0, I smaller than 3, and I plus plus. And we had a print statement here, right? So I'm not going to write it down. I'll leave it for later. What we could have done alternatively would have been to introduce, to declare and initialize the integer I outside this for loop. So we could have, let me just erase this. Yep, okay, so we erase it. Don't want to leave spot. Okay, there we go. So we could have done this. So we could have, so I should int I, sorry. Int I equals 0. We could have done this. And this wouldn't have changed anything at all. Also, we could have incremented I within the for loop. So we could have done this. So I plus plus here, somewhere within the for loop. You have so much flexibility in Java that you could even do this. So get rid of the conditional statement. By doing this, you create an infinite loop. A loop that would run forever. This is probably one of the most painful problems that programmers deal with every day. And you will definitely come across it. And the reason now we have an infinite loop is because there's no condition that is verified, right? So this is just going to run forever. And I'm actually going to write down an infinite loop and another example. And then I'll tell you what is, there's a way to identify infinite loops, especially when the programs are not that big. So let's just put this guy back here so we avoid our infinite loop. And doing this is really not a common practice. I mean, if you can, you always want to just have it here. But this, I've seen a lot. I've used it a lot because sometimes you want to increment it when something happens, right? So this, it's okay. So let me get another program here. So let me write down another program. So let's say we had public class iteration, and then so we had our main method. So public static void main, and then string args. Okay, let me just, okay. And then there's a bracket here. Open bracket, close bracket. So let's say I had my for loop here. So I had for int I equals 0, I smaller than 3, and I plus plus. And this is before this, right? So it's just want to make sure that, okay, so this is actually before this, right? It's above this. Anyway, so a really easy way to create an infinite loop is having this statement here. So having I is equal to 0. This would create an infinite loop. And this is because, if I write it down here, and if, let's say we had a print statement here, so we had system dot out dot print ln here, print ln, and I had just I here, and let me move this down here a little bit so it's not too clustered. So let me just get rid of this quickly. Okay, that's better. So let's say I had I equals 0 here. So this is better. Let's say I had this. Then what would happen is, well, initially I is set to 0, is declared as I equals 0. So you get, actually let me change this to yellow. So you get I is equal to 0, right? And then so you print it, right? 0 is smaller than 3, so you just get 0. And then what happens is that, again, I is assigned the value 0. It is redundant the first time that this for loop is running, so it's kind of, you just get 0. And then you reach the end, right? So I is incremented. So I is incremented, so then you get 1. And then you go back here, and this is obviously ignored, and 1 is smaller than 3, yes, so you just get 1. So you get 1. There's no dot here. You get 1 here. And then it's set to 0 again. But then it's incremented, so you get 1. And this pattern continues, right? So you just get this forever. But you always will get a print. The print you get here, what is printed to the screen will be 1. So you see now we have an infinite loop, and this is just going to continue. So you just get 1s, right? And the reason we were able to see this is because we have this print statement, and print statements are very useful generally when you're looking for errors, but especially when you have an infinite loop, because once you see this behavior, you know that you have your I, and I is being printed here, so you know that the problem is happening here, and let's say it was a bigger for loop, so there are more things inside, then you can investigate and find out where things are going wrong. So yeah, it is a good habit. It's a good to have in the beginning. I will see you in the next video.